The final topic in this section is about the areas between two curves. So suppose you have a curve called f of x on top and a curve called g of x on the bottom, and you want to know how much space there's between the two curves. Well, it turns out that this is nothing but an integral. So just find the integral and you're basically finished. Now, for this integral to work, the function that is on top, its name needs to be written first. So the top function always goes first. And the function that's on the bottom, whichever that one is, that goes second in the integral. So that's the bottom. Okay. The numbers on the integral themselves are the left and right bounds of the region. So the starting point and the end point, basically. So that's what you need to do. Once you get all the setup right, then you're pretty much basically finished. Okay. Now, the difficulty with these problems is that sometimes the curves cross one another, so they go kind of like this. And they don't tell you the start point and the end point, so you have to find them yourself. That's where this issue becomes difficult. But that's not terribly difficult. We can actually get the answers. So we're going to explain that in the next problem. So let's look at example number 5. So in this graph, you see the function f of x, which is the one in blue. So that's the f of x in this problem, 2x plus 1. It's just a straight line passing through 0, 1 right there. And you see in red the graph of g of x. The g of x is a parabola. It's x squared plus 1. It also goes through 0, 1 right there on the y-axis. So they both are passing through the same point, and we want the area of the region that is bounded by the graphs. Bounded just means that the borders are these two graphs. Now, if you look at all the possible areas, this is the only slice, this is the only area that has borders from left, right, top, and bottom. This one right here opens up forever to the left. This one down here is opening up forever towards all the sides, so on and so forth with all the other regions. This is the only region that's bounded by the red curve and the blue curve. It starts right there and it ends right there. We know where it starts. It starts on the x-axis at the number 0, but we don't know where the graph ends. So our first job is to find where the graph ends. So we need to know what that number right there is. And in order to do that, it's very simple, very straightforward. We just make the function f of x equal the function g of x. We just investigate what makes them equal. So in other terms, what makes the equation x squared plus 1 become equal to the equation of, x squared plus 1 is 2x plus 1. What makes it equal to the second equation, which is x squared plus 1. And to solve this problem, we just move everyone to one side. So I'm going to move the 1 over, I'm going to move the 2x over, and when I move everybody over, I get basically x squared minus 2x and equal to 0. By factoring, I can pull the x out, and then solving with the zero product property, I know that x is equal to 0, and that's the start point that I already knew. And the second point is going to be x equal to 2. That's the end point, and I kind of needed that number. We didn't know it ahead of time. So those are the two values, and now we're pretty much ready to go. Now to find the area that we're looking for, we have to just do an integral that starts at 0 and ends at 2, because that was the end point. So 0 is the start point, and 2 is the end point, and we had to research and find the 2 ourselves. Next, what we need to do is put the top function first minus the bottom function after with respect to x. So in other terms, who's the top function between 0 and 2? So ignore everything else that's going on in the world, ignore everything over here, just focus on the region from 0 to 2, which is the graph that is kind of towards the top of the page. Well, that's the blue graph, which means f of x needs to go first. Its equation is going to go first, minus who's the bottom graph? Who's towards the bottom of the paper? Well, it's the red picture, which is the g of x graph. And we're going to integrate everything with respect to x. So integral from 0 to 1, and the f of x in this case is 2x plus 1. I'm going to put parentheses around it just so I know that this whole thing was f of x. And then I'm going to put the minus g of x. And again, I'm going to surround the g of x with parentheses for two reasons. One, I want to keep track that they're all from the g of x part. Second, I want the minus to go to the first one and to the second one like it should. It needs to go to every one. And then the dx at the end. So this is very straightforward now. 2x plus 1 minus x squared minus 1 dx. Let's combine like terms. When you combine like terms, you get 2x minus x squared dx. And now we do the antiderivative. 2x squared over 2 minus x cubed over 3. And I keep writing 1. I'm not sure why I'm writing 1. It should be 0 and 2 for the integral. So now we're just going to put 2 and put 0. So when you put 0 in, when you put 2 in, what do you get? So again, the 2 is the higher one, so it goes in first. So 2 times 2 squared divided by 2, the whole thing is going to be 4. 2 goes in next. 2 cubed divided by 3 is going to be 8 over 3. So this is the upper bound. Minus, what do you get when you plug in the lower bound, which is in this case 0. So you plug in 0 into the x's and you just get 0 back. So the solution is going to be basically 4/3.